In this video, I am going to show you how we can increase the resolution of our datasets when we are working with remote sensing images. So in remote sensing, we are conducting pan-sharpening by merging high-resolution panchromatic and low-resolution multispectral images to create a single high-resolution color image. So by conducting pan-sharpening, it produces a high-resolution color image from 3 or 4 more low-resolution multispectral satellites, and plus a corresponding high-resolution panchromatic image. So in here what we are doing is that we combine the high-resolution grayscale band like panchromatic with the low-resolution color bands and create a high-resolution color image. So for an example, such band combinations are commonly bundled in satellite datasets, for example Landsat. So in Landsat there are bands which there are color bands which 30-meter resolution multispectral bands. However, there is another 60-meter thermal infrared band and also a 15 resolution panchromatic band. So when we work with Landsat dataset, we can increase the color band's resolution by combining with that 15-meter panchromatic band. So for this purpose, we are using a HSV based algorithm. So in here, HSV corresponds to hue, saturation and value. So let's see how we can conduct this pan sharpening process in Google Earth Engine. So for this example, I have already using the image that we have used for the previous example. So I'll give a little bit of introduction what we are doing here. And here I have selected the image Landsat 8 image collection, and then I imported a feature collection in order to filter the region that we are interested. And finally, in order to find out which area the least color image and for a particular period, I have used this code. So first of all, I got the image collection here and it filtered with the region, in which in this case the GN boundary, and then I filtered that data to this given period and then sort that images based on the cloud cover. And then I selected the first image, and basically what we are doing here, we are getting the least cloud cover image for this particular period and this particular region. And then in here I have added the layer into the Google Map. So first of all, when we are working with going to convert with panchromatic images, first we have to convert the selected image into HSV mode. So we can conduct that by RGB to HSV built-in function. So we can get the selected image here and then select the particular bands that we are going to convert into HSV format, and we can copy the bands that we are considering for the conversion. And then conduct the RGB to HSV conversion. And then we are swapping the panchromatic band and convert it back to RGB. So we can do that by So we are doing it with the concatenation function. So we select hue, and then select saturation, and finally we swap the value raster or the value band with the B8, which is the band. And finally we are going to convert it back to RGB. Likewise. So you can see it is quite straightforward, the method, and then finally we can add the pan-sharp image into the map. So we'll run the program. So the problem here that I'm facing is, so we have to select the B8 band from the Landsat filter, not the HSV convert. So we have to replace that variable. So let's run it again. So there is a syntax error. That is the reason it's not working. And now let's run it again. So I just forgot that we can't use this band combination when you are displaying the pan-sharp image, because these band combination are only available for the Landsat image. So likewise, we can conduct the pan-sharpening of remote sensing with Google Earth Engine. So previously I have shown you how we can conduct pan-sharpening to a natural color composite band combination. So apart from that, we can also conduct this pan-sharpening to different color combinations or different band combinations as well. So in here I have defined 4 variables for different band combinations. And the first one is that one we have conducted previously. And then in order to distinguish between land and water, we can use the band 5, 6 and 4 combination. So all these band combinations are available in this ArcGIS block. So depending on your requirement, you can select the best band combinations for your work. So if you are conducting agricultural analysis, you can use this 652 band combination. Or maybe you are conducting an vegetation analysis, you can conduct 654 band combination as well. So likewise, depending on your requirement, you can choose the best band combination and conduct pan sharpening to improve the resolution of your image. So for this first example, I'll replace the agriculture, and then used it to visualize and conduct a Pansharpening. So when you run the program, you can identify which areas are covered or maybe agricultural land. So when you zoom into these locations, you can clearly identify some fields are available, and with that band combination you can clearly identify which areas are used for agriculture. So let's see another one. You can use the urban. So from this band combination you can identify the which areas are urban areas, and here you can identify urban areas from the rest of the features. So in this way you can conduct the Pansharpening to other band combination as well. So I haven't changed much from our last code. So these lines of codes are almost similar to what we have conducted in here previously. So once you give a small basic color correction, standard color correction, you can visualize it, the Pansharpening image. So when you also zoom in, you can see how the resolution of that image has been increased once we conduct the Pansharpening. So that's it from this video. See you in the next.